Solar cells convert light into electricity, and you find them all over the place these days. I've got a radio here that's got a bank of solar cells in it. This is a little garden light, the sort of thing you have in your garden and it lights up at night. This is a torch, so you can see the solar cell here, and when I press the button the light comes on. It's all solar powered. Calculators, of course, sometimes are solar powered. This is a lovely thing. This is a bank of solar cells. You can see there's 3 solar cells here. And in the day it charges up an internal battery. And then you can use that to charge a mobile phone or an iPod while you're out and about. So it's great for travelling. You can even make solar cells that are flexible. Here you can see the solar cells on this sort of flexible sheet. And you can put this into your rucksack and go camping. And you've got electricity when you're out in the hills for your mobile phone or your GPS system. So in order to understand solar cells more, we need to understand how they work. So this is a photocell. It's a piece of semiconducting material, and it has 2 wires that come out of it. And I've connected up to my conductivity meter here, or my multimeter. And you can see that it's reading now. But if I put my hand over the cell to block the light, you can see that the meter reading changes. So what's happening actually is that as light falls on the semiconducting material, it creates electrons in it, which makes it conduct better. So it's almost as if it's acting like a wire. It conducts like a wire when light's shining on it. But when you block the light, it becomes insulating, like a plastic, for example. So you can use these for light switches and things. In fact, these are the sort of things you have in light meters in your camera, or even on street lights, so that they go off in the day and they go on at night. The thing is, they don't actually create electricity. As you block the light and you let the light on it, it's changing the conductivity, it's changing the resistance of the device, but it's not actually creating electricity. To create electricity, you need a much more sophisticated semiconducting device called a PN junction, which is actually what a solar cell is. And what you do there is you have a piece of semiconducting material and you dope it chemically with electrons, with a chemical that will give it electrons. And electrons are negative. So that's called an N-type semiconductor. And then you make another piece of semiconductor and you make it what's called a P-type semiconductor. That's got absence of electrons, actually called holes. It's a bit complicated. But basically, if you put the 2 together, you get a PN junction. And that actually will create electricity from light. And what you get is a device that when light falls on it, it only conducts electricity in one direction. So the energy falling on it creates electricity, creates electrons in the PN junction, and that produces a voltage at the 2 ends of the junction, and you can use that. One solar cell produces about 0.6 of a volt. So if you want to charge a 12-volt battery, you're going to need about 20 of these joined one together like a series circuit, like a daisy chain. And that's exactly what you do. If you want to charge a car battery, you need a bank of solar cells, about 20 of them, to give you 12 volts. And that's basically how the solar cell works. Let me show you a few things that I use solar cells for. This is a picture of my solar cell. This is on the office roof. And I use the power from this solar cell to charge a number of batteries. 2 of them are in here. This is my emergency light. So the solar cells continuously trickle charge these batteries. And if I ever lose the mains electricity, if there's a power cut, I've got about 4 hours of light here. So this is very useful. The next picture shows my amateur radio gear. I'm a licensed radio amateur. And this is my shortwave transmitter, and I can talk to people all around the world using this, and it's all solar powered. Now to the right of the device you see a little black box, and that's a regulator device, and these are quite cheap. They're sort of 10 to 15 pounds, $10 to $15, and they take the voltage from the solar cell and they regulate it so that I can't burn out my transceiver, my radio. And what it does is it charges up the battery. And when the battery starts to get fully charged, it just pulses the current until right at the end, maybe it's only pulsing it once a second every minute. And it just regulates the power going into the battery and makes everything much more safer, basically. You can't burn anything out. Now, what of the future? Well, a few years ago, physics, chemistry and engineering came together in a thing called nanotechnology. And this is where you can manipulate atoms to make very small structures, perhaps containing 100 or 1,000 or 10,000 atoms. And it's promising many amazing new developments for the future. And there's a lot of work going on in solar cells and nanotechnology. So they're looking at making little nano nanotechnological solar cells that perfectly match the light coming in from the sun to make them more efficient. They're also thinking of making them very dark so that when the light falls on them, they absorb all that energy rather than just reflecting it away. They're making flexible solar cells, and we hope in the future they'll be able to make batteries with a built-in sort of solar charger. So the batteries, you can leave them outside and they'll charge up. So you can imagine a mobile phone where the back of it is transparent, and you just leave it out for a few hours in the sunshine and it will charge up the batteries, and you'll be able to use your mobile phone at any time of the day. So nanotechnology is going to play key roles in the future of the solar cell.